Hey, hi everyone. Good evening, and hope everybody is doing very well. And welcome to today's session. Today we are going to talk about a project that our team has accomplished here. Very proud to proudly announce that the product has been successfully developed, and it is a milestone as a product as well. And very soon, this product will be going on floor on production on various clients. And this product is basically in supply chain, where we will be helping the logistic team with the last mile connectivity. This is basically to make sure that the products are appropriately delivered on time from the warehouses to the individuals who are ordering the product. This is in the logistic streams. And congratulating the team once again. And all the best for your future. And Sheila, you want to take over and explain the project. Of course, you'll also want to introduce the team as well. Please take over, Sheila.
Sure, Sharad. Sure, Sharad. Thank you. Hi, everyone. Good evening. I'm Sheila Vatsala. Today, I'm going to present regarding last mile connectivity, the first few slides about the details. First thing is, as we all understand what is the last mile connectivity, as Sharad sir has gave us a brief introduction about it. Can we go to the next slide, please? Yeah, first thing is I would like to take this opportunity to thank our mentors and our project sponsor, Sharad Chandra sir as our project sponsor, Mr. Abdul Jamil Sheikh as a project mentor, and Mr. Samrat sir as our project mentor again. Yeah, so we were able to do this project because of so many team members who put in their hard work in this project. And let me read out their names. Mr. Upendra Tiwari, Mr. Mohammad Ajmal Shah Ashif, Mr. Samtha Jain, Mr. Naga Shashidhar, Mr. Mohit Arora, Mr. Srinivas Tata, Y. Kiran Kumar, Mrs. Sheila Vatsala, that is me, Miss Pratyusha Mokapatti, Mr. Abid Hussain, Mr. Ashoka Chakravarti, Mr. Nehal Raj, Mr. Yagya Bharati Goswami, Ms. Pooja Mukunde, Ms. Chandana Sahu, Ms. Adikshna Chandra Vanshi. So coming back to the project details, like as we have already understood, last mile connectivity, this is to do with the last, as we understand regarding the supply chain management system, last mile term, as it suggests that it is the last leg of the transportation system. For example, in supply chain management and transportation planning, there's a movement of people or goods from one place to another, or maybe to the final destination. So there are several challenges where we come across, and a few of them to list out is minimizing cost, ensuring transparency, increasing efficiency, and improving infrastructure. Well, the last mile problem includes certain challenges of making deliveries in urban areas as well. Next slide, please. So as we understand, the supply chain management system starts with when the customer places the order using a website or through app or various means. Once the order is placed for a specific product, the order gets processed based on the availability. And once the process begins, the shipment starts from the source, wherever the product is ready for the shipment. And then it is then carried forward to the warehouse where the final destination is going to be. For example, if it is within India, or even if this is outside India, once the product is processed from the source, it is now taken through the various carriers, and then it further packed and pushed to the warehouse. This warehouse is what we look at as our first step. in our project, where the product is already at the warehouse and now it is ready to be dispatched to the customer address. Next slide, please. So in our project, we understand that the business objective as maximize on-time delivery, business constraints as reduce distance covered, minimize number of vehicles. Next. Initially, when we tried to understand the project, we first went ahead with understanding what possible machine learning algorithms that we could apply. And as so many other researchers did their process, like understanding the data available for them from the data warehouse, they went ahead with classification using different techniques like naive Bayes or network analytics. And after doing a lot of research by the team members, we decided to take k-means clustering as our first step to go ahead. And then we went ahead with vehicle routing problem algorithm. And next slide, please. In the workflow, as we all understand, the CRISP DM methodology, where we first understand the business understanding, which is the first stage. We clearly followed this method, and then we went ahead with data collection. We had various challenges while collecting the data. We reached out to different places, different location, and we tried to gather as much information as possible from the logistic point of view, because we wanted to be at the position of a manager in a logistics center, and try to gather information through them. So coming to data collection and data understanding, we try to gather the different attributes that would be required in order to perform the modeling, to perform various machine learning techniques. And we went ahead with the data preparation. In the process of data preparation, we found out some of these attributes that we initially thought were required, and then they were not required. So we decided to focus on certain attributes such as latitude and longitude and distance, which were much required for our route optimization process. So when we went ahead with data modeling, we applied our k-means clustering, and we understood how we could use the best possible k value to proceed with our further clustering. And then we went ahead with model evaluation using different techniques. And then we also went ahead with deploying it in the Flask, and then further iteration. Next slide, please. Well, this is the data that we initially were able to gather. The customer code, product code, delivery pin code, city, warehouse starting, latitude, longitude, present address, distance, time, date, and customer mobile. From our VRP problem, that is vehicle routing problem, we understood that latitude and longitude and distance are the key attributes for us. And we went ahead with doing a lot of EDA part on this. Next slide, please. Yeah, from here, the codes and functionalities, my friend Naga will be helping us in understanding this further. Thank you.
Hello all, I'm Naga Sasidhar, and I'll be taking you through the codes and the functionalities. So for this project, me and my team have made some codes to get the output, and they are eda.py, clustered latlong.py, geoplotting.py, and brp.py. Next slide, please. So coming to the very first code, exploratory data analysis, EDA. So this code gives you an idea about the data set that you got, and it also gives a quick review about the NA values and the correlation that is present between the distance and latitude and longitude coordinates. And it also gives you an idea about the latitude and longitude coordinates, how spread they are. And it is precisely executed on Spider and Jupyter Notebook. Next slide, Upendra. So this is the box plot that is formed by using the EDA. And as you are able to see that there are outliers both in the upper and lower case. And this is a box plot of distance And as you're able to see that green line as a median, there are more data points below the median. And next slide, please. So this is the bar plot that is taking the density as the y-axis and distance as the x-axis. Next slide, please, Chandra. So this is a pair plot, which is showing the relation amongst each and every attribute of the data set that we have generated. Next slide. So this is a bar plot between distance and time. Next slide. Upendra, next slide, please. So this is the geoplotting, and in geoplotting, we have taken the coordinates of latitude and longitude coordinates of them, and we have plotted it on map by using the folium map. And this folium map gives you an idea about how spread the distance, how spread the coordinates are. And this is the code that we have executed on Jupyter Notebook. And this is how the map looks like. Next slide. Yeah. So before I take you to cluster lat-long.py, I'll give a quick review about what a clustering is. Clustering is a machine learning technique which allows you to group some data points using the similarity and dissimilarity amongst them. So we have done clustering on the data points, that latitude and longitude data points, so that will reduce the bias while routing the sequence of the deliveries. So we have done the clustering on the latitude and longitude coordinates, and we have done that on the basis of the closeness amongst them. And this code splits the data into 3 parts, as we have taken 3 clusters, and it is executed on Spider. Next slide, please. Yeah. For example, let's see why clustering is necessary in our case. So let's consider this big circle as the warehouse, and all the small circles as the data points, delivery locations. So whenever we try to find the sequence on the basis of the distance from the warehouse to the delivery location, this point comes the first. And whenever we reach this point, and the next point would be this one. So all the way from here to here will be wasted. We need not to travel that way, and it will also add some burden on the delivery agent. So what we have done is we have clustered all these data points on the basis of the latitude and the longitude coordinates. Next slide, please, Pendra. So all these blue circles are cluster 1, and all these yellow circles are cluster 2, and the pink one is the warehouse. So after clustering, we are able to classify easily we are easily able to classify 2 clusters, and we can assign each cluster to one of the delivery agent, so that the delivery agent will not be needed to travel unnecessarily, and we can also optimize the route instead. So next slide, please. On the basis of this elbow curve that is formed in our code, we have formed the cluster. We have decided the number of clusters to be added, and there's a chance for us to take 2 or 3, and we took 3 clusters. Next slide, Kendra. So this is the cluster plot, K-means cluster plot, that can be provided by our code present in the drive. Next slide. So this is the cluster 1 file, data split, and this is the cluster 2, and this is the cluster 3. So these are the 3 data sets that are evolved from the main data set by our code. Next slide, Upendra. So vehicle route problemming, that will be taken care of by my team lead, Upendra. Upendra, take charge, can you?
Thank you, Naga, for giving me this opportunity. So before starting my presentation, good evening, everyone. This is Upendra Tiwari, and we'll be letting you know why we have used this vehicle routing planning. So up to this presentation, we got to know that we did EDA just to get the insight of the data, and we did the clustering. The main part of doing the cluster is that, since if we recall the business constraint of our problem statement, then the constraint was that we had to minimize the number of vehicle also. So what we did, we had decided that, first of all, let us see the distribution of addresses or the customers, and we found that our customer are mostly distributed in the three group. So that's why we decided that we will have the three number of vehicles, and we are roaming around this, and we will be implementing our optimization by keeping in mind that we are have to assign all the deliveries to these three vehicles only. So the main efficiency of the route optimization, that it will, since the route will be optimized, so obviously it will reduce the fuel cost, and also the maintenance of the vehicle. Since the delivery will be on time, though obviously the customer will get happy, and it will improve the customer experience. And this is doing the automate route planning. Before showing this map, let me show you the code that we have used. See, this is the vrp.py in which we have done the route optimization, where firstly what we had calculated the distance on the basis of the distance, the latitude and longitude. This latitude and longitude, on the basis of this, we calculate the distance matrix on the basis of the Haversine formula. Although we could have used the Manhattan and the Euclidean too, but if we have to use latitude and longitude, then Haversine is mostly preferred. After getting the distance matrix, we applied the route optimization algorithm, where first of all we initialize our warehouse as a depot, which is initialized as 0. That means every vehicle will start their journey from this warehouse only. This is the 0. Then we initialize the number of vehicles as a 3, because we had 3 number of clusters. So we thought that each vehicle will be taking care of 1 cluster. Then after this is the function which is taking care of the route optimization. And once the route is optimized and sequence has been generated, then it will be shown by a graph using the NetworkX library. So here you can see that we have used NetworkX for generating the graph, and just to show the routes in the graphical representation. So let me come back to my last mile connectivity. We have shown the route by using Tableau also, just to see that how the vehicles have to follow the sequences of the delivery. As we see, we know that for the visualization part, the Tableau and Power BI are very important. So that's why we have just implemented that on the Tableau, just to see the route of the vehicle. Then after, once we have optimized the route, then these are the sequences that have been generated for the 3 vehicles. Once the optimization will be done, then NetworkX will be showing the graph in this manner. And here you can see that this is the 0, which is the initial point for all the 3 vehicles. Just to segregate the vehicle, we have used the color coding. As you can see that here the purple color is showing for the vehicle 1, and the maroon color is showing for the vehicle 2, and this blue color, navy blue color is showing for the vehicle 3. It is just for making the difference between the vehicle, and this is the final outcome in the graphical representation of our project. So this is the future scope. So basically, before discussing this future scope, let me show you the video of our working model. As we have deployed our model on the Flask, so first of all, we'll have to move to the Anaconda prompt, and we'll have to reach in the drive where our code is present. So since the app.py is present in the E drive, so just and there is the folder inside the E drive. Just we did this. After this, we just written the command python app.py. The motto of this running this code command is to have the address of the server as well as the port number. So here we are using the default address of the local host, and we'll post that into the address bar of the browser. Let me pause this. If our model couldn't be run using the code, then we'll doing this video. So I'm just running this code. If that will not be able to run by the server, by the spider, then we will show it using the video. So I have written CMD. As you can see that I moved to the E drive, then this is in the project underscore LMC. Now when I have to type this code python app.py, when we have given this command, then it will be generating the address of the local host and the port number. So as you can see that here, this is the address is 127.0.01, and the port number is 5000. So we will just paste it on the web browser. When we have pasted here, so here two text box has been given as a latitude and longitude. Let me tell you that if you need to have the coordinates, then just I'm looking for example, coordinates of Delhi. Then this is the latitude of the Delhi. Just I'm pasting that into the latitude text box. Then after, we'll have to paste the longitude of the Delhi. We have just pasted it into the longitude, and when we'll be running on the clicking on this show route button, then it will show first the sequence of the delivery, and then after it will show the graph of the sequence. We'll have to wait for 30 seconds. Yeah, even you can see here the sequence of the route has been generated, and for vehicle 1 it is 0 to 8, then it will be reaching to 27, then after 47, and then 45, then 0. Same, the sequence for vehicle 2 has also been generated. This will be from 0 to 16, then 29, then 1, then 7, then 25, and so on. Same way for the vehicle 3, 0 to 2, then 19, then 14, and so on. Even you can see that using the graph also, that this is the 0, which is the central point and the warehouse point. After that, these 3 color coding, as I have already explained in my PPT presentation, that this will be showing the sequences of the route for each vehicle. So this is all about the working model of our project. Let me come to this future scope. As I have already speak that we have used the Tableau for the route visualization. So better part will be if we could be integrating this Tableau with our project, so that the route can be visualized in the better way, as well as if we could be able to deploy this on cloud, so that the efficiency of this project could be increased. So next I'll be handing over the presentation to Ajmal and Kiran, just to let you know that what kind of problem we have faced out. Kiran?
Yeah, thank you, Upendra sir. Good evening, guys. Thank you everyone for attending this presentation on last mile connectivity through YouTube Live. I am Kiran Kumar, and I'm here to discuss about the major challenges which we have faced during our project. So we have noted down all the major challenges with the solutions which we have opted to tackle these challenges. So the first challenge was the data. So we have created our own data for this project. First, all of our group members have discussed and decided what are the major fields or the appropriate columns to be developed to make the route optimization model. And after finalizing on the features, we have extracted the data from Makaru and data generator websites. Next slide, please. So after extracting the data from these websites with great difficulty, we have found that many of the cells were empty. Mainly the latitude and longitude data were empty. So we had to extract the latitude and longitude coordinates with respect to that particular address again. Next slide, please. So the other problem which we have faced was extracting the coordinates from the address. So we thought of extracting the coordinates from the address itself, but in order to do that, we can use Google services, for which we require an API key. And API key is associated with cost. So we have searched for other alternatives for extracting this API, this key. So we thought that why don't we use the coordinates itself for plotting? So at last we have finalized that we will be using the coordinates to do the vehicle routing problem. So these were the few challenges which we have faced. Now our friend Ajmal will be listing few more challenges. Over to you, Ajmal.
Thank you, Kiran. Myself, Mohammad Ajmal Asif. Good evening to all, guys. Other challenge we have faced in VRP, that means vehicle route planning algorithm. In that, while routing the routes, we faced the problem in distance metrics. Like we tried Manhattan distance and equivalent distance, but we not satisfied about the result what we have get. So we gone through another distance metrics called Haversine distance method, which is very providing the good result for our model. So next slide, please, Upendra. And another problem we have faced that plotting the delivery sequence we have. So to show for better visualization, we use Tableau, and we for the graphical representation we use Network X, and some references used from iGraph and JGraph. And next slide, please. And other challenges we face in geocoding. That major challenge we face to accessing the Google Maps. For accessing the Google Maps, we need a paid API key. So it is to cut the cost, we need to set some alternate method to use some Google Map service, which is under some free Folium library we have used. In that Folium, because that package is already available in the Python, so it is easy to use and also free. So and is used for the plotting the coordinates also. And thank you all.
Thank you, Kiran and Ajmal, for giving this a nice presentation. Now we all are open for the any query if you guys have, then we'll be happy to answer them. Is there any query? Let me open the YouTube channel.
This coordinator-based dispatch method, it raised some management issues such as the libraries. And our solutions was based on the data that alumni has collected to offer an intelligent.
I think there is no query. So, Sarath sir, can we conclude our presentation? So thank you, everyone. It was a great meeting with you all. Thank you so much for listening us patiently. Good evening, good night. Thank you, everyone. Thank you all.